Assess validity of stated preference contingent behavior responses. That's a long title. Go ahead, Lucy.
Thanks, Philip. Yeah, good afternoon, everyone. Thanks for coming to this brown bag talk. It's a beautiful afternoon outside. I hope it's also beautiful in Delaware, right, Mike? And today I'm going to talk about a paper that uses economic experiments to understand stated preference surveys with my co-authors listed here. I personally had a lot of fun working on this paper because we were able to do everything online during the pandemic. And of course, we wouldn't be able to make everything happen without the funding support from April and help from Janji and Kelly. And as Philip said, the title seems long and maybe also seems a little bit abstract. But don't worry, I'm going to walk you through contingent behavior and validity to motivate this study. And I'm going to spend most of time talking about the experiments. Also, you probably have already noticed that I tend to talk fast. In case I wrap out stuff, then just feel free to jump in if you have any questions or comments, because we really hope to get some feedback on this paper. So the first question I want to answer, or you might have, is what is contingent behavior? We actually had a discussion within our group. So these two words, contingent and behavior, is behavior contingent on something. The behavior we are looking at in this paper is intended behavior in quantities or frequencies. And that something is hypothetical scenarios. So put them together, contingent behavior is a stated preference method that is used in environmental economics or other literatures where field or natural experiments are not feasible. I think the beauty of the stated preference method is really in the hypothetical scenarios where researchers can implement randomization of the changes in prices, qualities, or other attributes that they are interested in. For example, in recreation demand studies that look at recreational activities, contingent behavior trip data is usually combined with reviewed preference RP data to add variation for models estimation. And CB has also been used to assess market demand for new products. Here are two timely examples. So the good thing is we are close to Christmas, and the bad thing is we are still in COVID time. The statements after if are to propose hypothetical scenarios. As you can see, none of these are true, at least for now. And the statement after how many are the actual CB questions. And you can see it's how many times that is in frequencies and how many chocolates that are in quantities. From the literature, there are two examples. The one above proposes to change cost or prices and ask for, again, quantities, how many trips. And the one below proposes to change attributes. That is similar to the presentation in choice experiments, but it asks for frequencies as opposed to a choice. So I hope you already get that sense that the contingent behavior we are looking at here really asking for quantities or frequencies rather than eliciting values as in the contingent valuation and choice experiments. So regardless of that difference, contingent behavior is still a stated preference method that is hypothetical in nature. And the question will be how accurate they are. And in social science and also in non-market valuation, the true values or true intended behavior are not easily observed. So the accuracy is usually measured by validity and reliability. Validity is the focus of this paper, and you usually assess how unbiasedness of estimate from a non-market method. And in particular, there are three types of validity assessments: criterion, construct, or convergent, and content validity. This paper looks at criterion and convergent validity. The criterion validity is like an ideal validity assessment by comparing ST estimates with a gold standard criterion that usually includes real money payments. And because of this criterion, it usually requires additional data sources rather than from the static preference surveys. So it's quite challenging to do criterion validity in the field, and experiments have been used quite a bit to assess criterion validity. Convergent validity can be done through the field surveys only, and it usually compares SP versus the parallel RP estimates. Now, where we are in terms of contingent behavior validity assessments. In the previous studies, the convergent validity has drawn quite a bit attention, usually using the data from the field surveys. What's usually been done is researchers will send out multiple surveys to the same individuals across years. For example, in year 1, they will send out a survey to collect RP and CB responses. So the RP responses were from the questions asking people what they actually did in year 1. And the CB responses were usually from the questions asking people what they would do given a hypothetical scenario, or to ask people to predict what they would do in year 2. And in year 2, then another survey will be sent out to the same individual, asking people to recall what they actually did in year 2 to collect another RP responses. So with the RP, CB, RP data together, they can test the convergence in using various model specifications. But the results are mixed in terms of whether CB is valid regarding convergence with the subsequent RP responses. Also, none of the study, as far as we know, have assessed criterion validity. Then what do people do with criterion validity in the literature? Previous research focuses mostly on the contingent valuation and choice experiments, especially to value public goods. And lots of efforts have been put into the discussion on incentive compatibility, both theoretically and empirically, because the biggest criticism to the static preference methods are they are not incentive compatible. And it's also the very important requirement for a criterion to be used in the validity assessment. Empirically, especially through experiments, what has been usually done is people would design an incentive compatible decision mechanism as a criterion and design treatments with hypothetical natures and to mimic static preference methods and compare the criterion with the treatments and to detect hypothetical bias and strategic behavior. The studies have been quite advanced regarding evaluating public goods, but for private goods, the research is still quite ongoing and active. Empirically, it has been found that hypothetical bias is likely to subject to provision bias and price bias for valuing private goods. The provision bias refers to the case where people tend to overstate their values for a new product to increase the chance of that product being provided on the market. But they don't actually have to buy it when the product is actually on the market. And on the contrary, price bias is usually assessed, usually refers to the case where individuals tend to understate the values for an existing good to signal a high price sensitivity in case someone would increase the price. Interestingly, none of these lessons or discussions here have been adapted or translated to CB criterion validity, which gives us the opportunity to do this project. And here we argue that it's equally important to assess criterion validity for contingent behavior for 3 reasons. The first one is it's a stated preference method, so it has that hypothetical nature, and it's probably was subject to hypothetical bias, but we don't know for sure. And the second one is the CB methods are usually used to elicit preferences towards private goods with public goods characteristics. What does that mean? Thinking of a recreation activity or recreation trip, it's private for the recreationist, but the site attributes, for example, the wildlife population, is public to people, and as a result, the CB responses could be subject to provision and price bias. Again, we don't know for sure. And the third reason for doing this is we think assessing criterion validity will add values to convergent validity and help with the applications of CB methods. So the objective of this paper is looking at to assess the validity of stated preference contingent behavior methods. I hope it's less abstract now. And the approach we use is economic experiments. And the first step to do it is to design an incentive compatible decision mechanism, because it's quite important in the validity assessment. Also, we elicit preferences by asking quantity decisions. And in terms of the validity assessments, the criterion validity focuses on the between subject comparisons, which follows the criterion validity assessments for CB and CE. And the convergent validity assessments focuses on the within subject comparisons. That is to mimic what has been done in the field surveys. And here is a preview of the findings. The first one is hypothetical bias is found to exist in CB responses from our experiments, and individuals tend to overstate their intended behavior. The second one is framing does not significantly affect hypothetical bias, which is a little bit surprising compared to the previous studies. Interestingly, we do find that framing would affect the convergence of CB and subsequent RP responses. And we also find that individuals' experience with the goods or attributes would improve the convergence. That is from a supplementary analysis. So this study makes 3 contributions to the literature. For experimental economics, we designed an incentive compatible decision mechanism that elicit individuals' preferences by asking quantity decisions, that how many goods or how many times, as opposed to value that is usually being asked in auctions. And for stated preference literature, this study is the first, to the best of our knowledge, to test criterion validity with of CB responses with an incentive compatible criterion. And it's also the first to provide experimental evidence on convergent validity of CB responses. So here is a brief summary of the paper, and the rest of the talk, I'm going to talk about the experiments. The first step in the experiments is to design a decision mechanism. Specifically, they have to be incentive compatible. Why we couldn't use what people have used before is because for auction mechanisms, usually individuals decide on their willingness to pay or willingness to accept, but it's also always the value. And for the research objective, we want to elicit preference towards quantities. So we need to design a new kind of mechanism. And in our experiments, individuals make multiple decisions on how many units of goods they want to purchase at various per unit prices. After that decision, after they have made all the decisions, one of the decisions is randomly selected for the actual transaction, where people have to buy the number of goods they indicated at the prices in that selected decision. And this random selection is to ensure the incentive compatibility of the design, and it's always the requirement for economic experiments. And and for this study, we use this incentive compatible decision mechanism as a criterion to assess criterion validity, and also use it to collect RP responses for convergent validity. Why we think it's a good way to collect RP responses is because people would usually think RP responses are incentive compatible. And with that decision mechanism in hand, we designed this experimental procedures that consisted of 3 parts: effort task, purchase decisions, and debriefing survey. So everyone went through all those 3 parts. The first part, effort task, is there are 2 kind of effort tasks. One is to count zero, another is to encode words. So this is for participants to earn money to spend in the main purchase decision. And it's also a common practice to remedy for the house money effect in experimental economics. The main part of this one is the experiment is the purchase decisions that consisted of 18 decisions. And the 18 decisions were evenly distributed throughout 3 stages. Stages 1 and 3 are called selection stage because they are part of the random selection. So they are non-hypothetical and incentive compatible. And the stage 2 is the survey stage. So that is to mimic SP surveys. And some of them are hypothetical and some of them are not hypothetical. And so with this within subject design, then you can see an RP, CB, RP responses that mimics the CB surveys or convergent validity assessments with CB survey data. The goods we use in the experiments are chocolates, so high-end chocolates. These are private goods. That's no one would argue with me. And the attributes we use, or the attribute with public goods characteristic we use is the donation option. So we call them as an upgraded good. So that's the best we can do in a lab experiment to mimic something like recreation trips with as a private goods with public goods component. And the last part is the design. The within subject design comes into the stage 2 that I'm going to talk in a bit. Control group made non-hypothetical decisions, whereas treatment groups made hypothetical decisions. Now let's come to the interesting part is what are the chocolates we auctioned off? So we chose the JSIC chocolate because it seems to be famous and I heard it's good. And we try to provide as much information as we can in the experiments because it's online and it doesn't have enough, it's not as concrete as if we do it in person. So, with those information, we reminded people about their earnings from the effort task and also tell them the price per unit. We have 6 pre-selected prices And with all those information, we ask people to enter how many chocolates they want to buy at those prices. And that is for only in the stage 1. And in the stages 2 and 3, everything else is held constant. And the only thing we added in is the donation part. And in order to make us look more credible, we also add the Edmonton Food Bank's logo. And so these are the decision screen that people look throughout the experiments. So as I've mentioned, the treatments or the between subject comparisons comes into stage 2. Control groups made non-hypothetical decisions that are the same throughout. And the treatment groups made hypothetical decisions. So all of the participants in the treatment groups were told they are going to make hypothetical decisions, and they also know they knew they would have a selection stage with real money decisions or non-hypothetical decisions afterwards. And participants in treatment 1, hypothetical baseline, were asked to make decisions as if they were actually making a real money decision. The language here is subjunctive language, and that is adapted from the SP surveys. So from here, you see we didn't use any like directional framing, and we didn't intend to induce overstating or understating. Treatment 2, the participants, hypothetical provision participants were told their decisions affected whether they would be presented with stage 3. So if the total number of chocolates in the session indicated by the participants was large enough to pass a threshold, then they will be presented with the stage 3 to make real money decisions. And you can see that in this treatment, we are hoping to induce overstating caused by the provision bias. So what's the difference between the two treatments? First is the framing. So T1 does not have directional framing. So the framing is non-directional, and T2 has the directional framing. Also, hypothetical decisions in T1 do not have any consequences on participants' real money payout, but these hypothetical decisions in T2 might have consequences on the participants' payout if the randomly selected decisions were found stage 3. And here are some details about the experiments and participants. So it's a classic subject pool for lab experiments, and we use it quite often. And everything was done online. Everyone was invited into a website and also a synchronous Zoom session, so we can monitor both. And the average payoff was around $27, and we couldn't pay people in cash, so we had to go through quite a bit of procedure to make to use Amazon gift cards. Also, about 1 chocolate was purchased on average. So here is a table of the mean values for the variables that we collected. As you can see, the subject pool is classic, so the mean values are quite close across treatment groups, but they are not balanced. So we included them in the analysis. And then here is the demand curves that we are trying to trace out by using experiments. I'm not going to go in details of those graphs. The main takeaway is that you can see the difference between control group and treatment groups. And those the differences help us to do the between subject comparisons. And also within each panel, you see the difference between colored line and gray line. And these are for the within subject comparisons. So here is an overview of the results, or the and our analysis really try to follow 3 questions. The first 2 are in criterion validity, and the third one is for the convergent validity. The first question is to detect whether there's a hypothetical bias. So by comparing treatments and control, so we don't care about how large or the and direction of the hypothetical bias. And the second question is to look at how the framing would affect hypothetical bias. So whether people would understate or overstate, or they don't respond. By doing so, we compare T1 and T2. So the outcome variables we use in the analysis are quantity decisions and quantity premiums. That is the difference between quantity decisions of stage 2 and 1. The main reason for this is we see that there's a difference across groups in the stage 1, and using that quantity premium, we can control for that difference. And also it has its own meaning for recreation demand studies. To construct the outcome variables, we use quantity decisions in stage 2 or stage 1 or 2. And the third question is on the convergent validity. Basically, we want to see whether the blue line and red line would converge or overlap. And to do so, we use quantity decisions within each treatment group and for the analysis. So for the convergent validity, these 2 graphs shows what we do with the non-parametric test. To detect the existence of hypothetical bias, then we test the equivalence of dots on the blue line or red line versus the dots on the green line, and similarly for blue or red bars versus the gray bar. And to compare the 2 treatments to see the framing impacts, then we test the equivalence of dots on the blue lines and red lines, also, or the dots on the blue bars or red bars. And here are what we have found. By comparing treatment groups with the control group, we do find hypothetical bias because those 2 quantity decisions or quantity premiums are significantly different. And the second one is to compare 2 treatment groups. And we only find significant differences for these 2 prices, like this 4 dots basically. And therefore we think framing might affect the magnitude of the hypothetical bias at lower prices, but not overall. And to further examine these questions, we ran 2 OS regressions with the 2 outcome variables here, and the variables of interest are treatment dummy variables, and we control for prices and demographics. So it's quite busy here, but you just need to notice that those coefficients are significant, means treatment groups are significantly different from the control group. So it's an indication of hypothetical bias. And those coefficients are positive. So that means the hypothetical bias is from an overstatement. And that kind of answers the first question. And then we want to know whether there is an impact of framing. And we test the equivalence of the 2 coefficients in 2 models. So in the first one, T1 and T2 are significantly different, but only at 10% levels. And they are not significantly different in model 2. So it's not a really strong evidence of that framing does have an impact on hypothetical bias. And the thing is, when we design the T2, we hope to induce provision bias, but we don't find the provision bias. And interestingly or the puzzle part is we do find the overstatement, and we cannot test or understand, we are not able to understand what what are the motivations that drive the overstatement. And that is also common for T1 and T2. So, so our guess is that it might have to, it's probably something have to do with the attributes we use, the donation, because it has that public goods component. So, and potential reason might be social desirability bias or warm glow. But with the current design, we are not to identify those. And we hope to get some ideas to interpret this result. And for convergent validity, the question we want to answer is, do individuals' CB and RP responses converge? Then using, also we run two OS regressions, and the hypothetical decision dummy variable or the indicator of CB responses is our interest. And for those, so the interesting part here is we see CB responses are significantly different from RP responses in treatment 1, but it's not significantly different from the RP responses. So it means indicating that CB and RP responses do not converge in T1, but do converge in T2. And the difference between the two treatments are the framing. And then we can say framing might affect the convergence of CB and RP responses. We also did a supplementary analysis to for the T1, and because it has been found that participants or respondents who have experience with the good or attributes assessed might be better to predict or provide more accurate responses. So we split the sample based on whether participants donated or volunteered at the food bank before. And we found that the non-convergence appeared to be driven by those individuals who are not familiar with the food bank. Oops. And here is a summary of the findings. Basically, three findings. First, we find hypothetical bias associated with an overstatement in the contingent behavior responses. And this hypothetical bias is not significantly affected by framing. And we do not have a strong evidence of the provision bias on average. If there's anything, then probably the provision bias would have a little bit impact when the prices are low. And there are other factors that might induce the hypothetical bias, but we don't know with the current design. And for convergent validity, we find that framing does affect the convergent validity of CB responses versus RP responses. So the directional and consequential framing, the T2 would help improve the convergent validity as opposed to the subjunctive and inconsequential framing in T1. And potential reason is the prior experience with the attributes. And also we guess that it's possible that for participants in T2, when they indicated what they want to buy a lot of chocolates to get T3, they feel when they were actually provided with that with the stage 3, they feel they have to commit to buy as many chocolates as they indicated in stage 2. Again, it's a conjecture. So the endpoint or the goal for doing a very kind of controlled lab experiments is to provide some implications for CB researchers who use CB methods in the field. Because we do not we find hypothetical bias, then we recommend that people have to improve the incentive compatibility in the survey design. All those laundry lists here are either borrowed from the recommendations for CB and CE, or it has something to do with our findings like past experience and perceived consequentiality. And again, it's better to not to use the directional framing. Use neutral framing might be better. And for the survey sampling and data analysis, the main point is to first to account for heterogeneity, because we do find different responses from the participants. Also, we find differences between CB and RP data. It's better to distinguish CB from the RP data if one puts two types of data into one model. The easiest way is just to use a dummy variable to indicate the difference. And the last one is just something that I think people can do, but it's not for sure. So this study also has its own limitations and needs future investigation. The first one, which is the biggest puzzle, is we don't know what causes people to overstate. And the second one, I talk about the price bias, but we didn't test it in this design. And the third one is it's still a quite abstract experiments with chocolates, whereas the CB studies is usually have that recreation activity context. So this study does not have that framing and can be changed in the future research. And the last thing I want to point out about the future research is how to the choosing of appropriate validity test. The interesting part of our design is we use an incentive compatible criterion to assess criterion validity and also to assess convergent validity. This hasn't been done in the previous studies. So, and we find different kind of impacts for framing impacts. And then it raises a question of which kind of validity test we need to use and which one for a specific context. And with that, I would like to thank you for your attention. And here is a graph to show the real fun or pain of doing experiments and shipping chocolates. Thank you.
Thank you, Lucy. Thank you very much. I'm sure there are questions coming.
I'm going to make one comment. I'm going to tell you that the chocolates actually are very good. Okay. I've consumed several, and just to follow up on Lucy's last point, I think there are some really interesting puzzles. Like, why didn't the provision framing actually generate an increased provision bias as a puzzle? And this issue of what's the right validity test when they go two different directions is also a puzzle that we didn't think of when we started down this path.
Any comments?
Hey, Lucy, I have a question. Yeah. One question for Lucy is, I took part in one of the studies that you did. Were you only sampling students from the department or anywhere else?
So it's the REES subject pool. So it mostly
okay.
from the university. And
right.
sometimes it has some stops, but not a lot.
Okay. And another question, because I'm also working on trying to do experiment design online. It's more directed to Jacob, who I see is on the call. And I'm wondering if what kind of operating system did you use? Did you use O-Tree or a Django framework?
So yeah, we hosted this on AWS, which worked really well, Amazon Web Services. For this one, we used Django and Python and just kind of coded it, from scratch. I've actually been working on another one since then, which is also in Python, but instead of Django, I've been using Flask, which is a little bit more pared down and flexible, which I think works a little bit better for experiments. I'd be glad to talk about the technology all day, but if you want to drop me an email and follow up or something, feel free to.
Okay, appreciate it. Thanks.
Yep, sure.
And yeah, I could also attest that the chocolates were really good. I think I ordered 3 of them, and they got to me right on time. So thanks, Lucy.
Thank you. Any questions?
I have a question. Did you, so you find that essentially you cannot disentangle between social desirability and the warm glow? Did you think about an experiment to dissociate them? I mean, that would be a future work, of course.
Yeah. Well, actually, these 2 motivation, we just came thought about it last week, because before we only just think about the provision bias, and that's definitely worth a try for the future work. But I'm not quite sure how to. So in the future, one would be thinking of a whole list of reasons for overstating, maybe provision bias, warm glow, and social desirability bias. And I have not thought about how to make it happen. I'm not sure if it's okay to answer you.
Okay, that's okay. It's a difficult question. I don't have an idea right now.
I'm gonna say, you have some suggestions? Because I mean, we've tried to do some things with field experiments and teasing out social desirability bias. It's a really interesting topic, because I think, you know, any of these kinds of intention statements, and to a certain extent real purchases, could suffer, if that's the word, from social desirability bias, or could exhibit social desirability bias.
Yeah. I guess something that might elicit is whether your actions are public or not. It might give a clue to the rest of the people what your intentions are when you're making decisions that are socially useful, let's say this way. But I mean, out of the blue like that, it seems difficult to. There's a real experiment to be built to separate both of his intention, I guess.
Yeah,
Well,
Jason Lusk did some work years ago where he tried to do that by varying the good. So he had some goods that were sort of environmentally friendly that he thought would generate social desirability, and then he had like salt or something like that. Use some very sort of neutral goods, and that, so he set it up where the goods were either characterized by social desirability or not. So that might be an avenue.
Yeah.
But there's some downsides to that too. It's a really cool question.
Well, I mean, to some extent, that seems like it's the mirror side of some of the deception work that's been done, right? There's been a lot of really interesting things done on that using kind of unobserved actions where you can measure the aggregate result and things like that to see if there's, you know, when things are observed, not observed, if there's a change in kind of the average that you can view, even if you can't view individual results.
Yeah, Jacob, you mean sort of when somebody really knows that they're completely anonymous in their choices versus if their choices are being observed.
Yeah, exactly.
Any question? Don't be shy.
I know this paper is quite kind of methodological, so I put in so much definitions. And yeah, if you need any clarification, I'm happy to take it.
Okay. No more questions? Okay. That's good. That's okay. Thank you, Lucy. That was a very presentation. So next, it's the last actually brand bag of the this semester. So in January we'll have another brand bag with Monica Chandal, another graduate student of REES, presenting in January 21, I think. I thank everybody for coming. Lucy, that was very interesting. I think you might want to use a little less acronyms and when you present, because it's easy for someone, I mean, like me, was not very knowledgeable about all these terms to get lost, and that explains a little bit why I'm out of question here.
Thank you.
But
yeah, I would do that. It's just like
very nice.
Thank you. All of those terms are super long. Thank you. Thanks, everyone.
Nice job, Lucy.
Thank you.